Okay, for this question we are going through power series BMQ question 2A. So this question is from power series tutorial. Okay, so this question is from power series tutorial. So we're going to use the expansion of ln 1 plus x to explain ln 1 minus 2x squared. Okay, what is the expansion of ln 1 plus x squared? Okay, so over here, all we are doing is we are taking it from MF26. Okay, MF26 will tell us that ln 1 plus x, right? Okay, based on MF26 is nothing but x minus x squared over 2 plus x cubed over 3. Okay, that's for MF26. Nothing, since you're just using for that without using any thinking at all. Okay, now we need to expand ln 1 minus 2 squared. So how do we expand ln minus 2 squared looking at this? So if intuitively you can see, all we need to do is we need to sub x here. We need to replace with minus 2x squared. That's all we need to do. So we need to replace this with minus square, so 2x squared. And in fact that is all we need to do. Okay, so all we're doing is we just replace our x. Okay, so if we erase the x, we just put down, erase the x, right? I'm gonna put minus 2x squared. Okay, erase one more time. Over here, I'll erase all the x, I'll put minus 2x squared. Okay, this is x squared, so I'm going to erase the x again. This is minus 2x square. And remember there was a power 2 just now, so it's square. Okay, last one is x cubed over 3. Now do we need x cubed over 3? So all we need to do is do up to the term x power 4, right? So if we have if we were to put x cubed over 3 here, it's going to give us a negative 2x cubed to the power of 3, and this is x to the power of 6. Okay, so this is x to the power of 6, so we don't need it. Because we don't need it, we can just erase it away. Alright, so these are the only two terms that we need. Okay, and we want to simplify our answer. That's going to give us approximately negative 2x squared minus 2x to the power of 4. Okay, now again, make sure we need to give the validity range. So for power series, we always need to state the validity range. So for validity range, what is the validity range? We want, again, the variable term to be less than a constant term. So this means that we want negative 2x squared to be less than 1. Alright, and for it to be less than 1, that means can you say we want x squared? Okay, so we want, okay, let's go to the next page. Okay, so if we have negative 2x squared to be less than 1, okay, this means that we are saying negative 2x squared is between 1 and negative 1, correct? Okay, so let's consider negative 1 lesser than negative 2x squared. Now subtracting both sides by a negative number, we have 1 more than 2x squared, or 2x squared less than 1, or x squared less than 1 over 2. X is between 1 over square root 2 and negative 1 over square root 2. Now for the other side, negative 2x squared less than 1. This means that x squared is we divide both sides by negative 2, we have x squared to be more than negative half. Okay, which does not really make any sense, because we already know that x squared, since x squared is already greater than or equals to 0 for all x, therefore this does not provide us with any solution. This does not provide us with any solution. So I mean, looking at this answer, it's just going to give us x to be. Okay, this is true for all values of x. So this is true for all x. Okay, so taking the intersection of both answers, we know that this is true for all x. Here, x is between negative 1 over 2. The final validity range that we want is eventually this. So this is the true intersection. So the answer, if you go back just now, this one is true, valid for negative 1 over square root 2 less than x less than 1 over square root 2. That's the end of 2A. Okay, now after that, we go to 2B. 2B asks us to use the Maclaurin theorem to obtain the series expansion. So you realize that actually from here, if you were to use Maclaurin, it's going to give you the same answer That's what you do for power series. Because remember we've seen before in tutorial that they will give you the same thing. Right, so using Maclaurin theorem, what we do first, okay, okay, this is going to be a long one. Okay, so first we recognize that f of x, this is equals to ln 1 minus 2x squared, right? And from here we need to find what's f prime. Okay, so f prime, okay, I'm not going to go into the detail part, okay, but I'm going to show you the f prime. Okay, so it is the same as I differentiate fx, so this is a negative 4 over 1 minus 2x squared. Okay, differentiating again, so while differentiating this, you need to do quite a bit of work. Okay, you need to actually do a quotient rule. Your f prime double prime x, right, is going to be negative 4 1 minus 2x. So 1 minus 2x squared to the power of negative 1. Okay, so this is done by differentiating f prime x again. So I'll leave the differentiating to you. It's actually quite a tedious process. Okay, so this question is quite long. This will be your f prime x. Okay, what about f triple prime? F triple prime, again, you need to differentiate one because Maclaurin theorem means that you know what's the Maclaurin theorem. Okay, so based on M26, we know this is fx equals to f of 0 plus f prime 0 x plus f double prime 0 over 2 factorial x squared plus f triple prime 0 over 3 factorial x cubed plus f of 4, the fourth derivative, 4 factorial 0 x power 4, so on and so forth. So that means if you look at all this, it shows that we need to differentiate once, differentiate twice, differentiate 3 times, differentiate 4 times. Okay, so that's why we need to find all the way up to the third and fourth derivative. Okay, so again, you need to differentiate one more time, and your third derivative should give you f triple prime x should be equals to negative 48 1 minus 2x squared to the power of negative 2 minus 128 x cubed 1 minus 2x squared to the power of negative 3. Okay, one more time you differentiate again. Okay, so remember this, when we differentiate the fourth time, we put a bracket on the 4, so this is not a composite function. Okay, so this is equals to negative 48 multiplied by 1 minus 2x squared to the power of negative 2 minus 768 x squared 1 minus 2x squared to the power of negative 3 minus 1536 x power 4 1 minus 2x squared to the power of negative 4. Okay, now from here, then you need to slowly substitute everything, substitute fx equal to 0. Okay, so let's look at the first one. If I sub f as 0, let's say I sub this as 0, this will be 1, 2 of 0, this will just give me ln 1, which is 0. Okay, looking at f prime 0, if I sub f prime 0, since the top is going to give me 0, 0, this is going to give me 4 times 0 divided by anything is still 0, so it's going to be 0 again. Okay, f double prime 0 is going to be a bit nicer, so this will be 0, this will be 0, this whole thing is going to give me 0 again. 4, this is 0, so this is negative 4 times 1 to the power of negative 1, so this will just be f double prime 0 will just be negative 4. Okay, what about f triple prime? F triple prime is going to give me 0 again. Okay, so this whole thing, f triple prime is going to give me 0. f of 4, 0 is going to be negative 48. Now you can verify this for yourself. Just substitute 0 into this expression. Okay. Okay, then with that, you have ln. Remember that you want your function square using Maclaurin expansion. you are looking at f0. Remember, this is the formula: f0 f prime 0 x plus f double prime 0 2 factorial x square plus f triple prime 0 3 factorial x cube plus f4 0 4 factorial x power 4. Okay, so now all you do is sub. We know that f0 from just now, f0 is 0, f double prime 0 is 0, f double prime is negative 4. Okay, we just go to this. Okay, so this is going to be 0. This is going to be 0 as well. F double prime 0 is negative 4. So we have negative 4 over 2 factorial. Negative 4 over 2 factorial is just negative 2. F triple prime is 0, so this will disappear as well. This will be 0. F4 of 0 is negative 48. Okay, so this one will be negative 48. Okay, and simplifying everything, you see that everything will disappear. You're just left with negative 2x squared, negative the coefficient x power 2 and the coefficient x power 4. Now simplifying this is just this is 48 over 4 factorial, which is 4 factorial is 24. So negative 48 over 24 will just give you 2. Okay, so the final answer, the Maclaurin expansion for ln 1 minus 2x squared will just be approximately negative 2x squared minus 2x to the power of 4. And you can see that this is actually the same as the power series expansion. Remember? Okay, so we were doing this just now. What was the Maclaurin expansion? Can you see it's the same? When you go backwards and look at the Maclaurin expansion, you get the same answer. Okay, so actually both of them will give you the same answer.